The function f is defined as shown with domain between 0 and 2 pi, and we're asked to solve the equations f dash x equals 0, so the stationary points of f, and the second derivative equaling 0. So f dash x, let's differentiate, we're going to get minus sine x plus root 3 cos x. And then let's set it equal to 0. So that means sine x is going to equal root 3 cos x. So sine x over cos x is going to be root 3, which becomes tan x equal to root 3. You might even know your exact trig values, because this is in degrees would be 60 degrees, and in radians would therefore be pi over 3. But by all means, put your calculator in radians mode, and then do inverse tan of root 3. So we get pi over 3. Okay, tan graph. It repeats every pi radians, every 180. So I've got an answer here. I just need to add on pi to get the next one. So I'm going to get 4 pi over 3. With cast diagrams, we're here and we're here. And again, you can see we got this angle, and then we need to go all the way around to here. So we're adding on pi there as well. Right, next up is the second derivative. So I just differentiate again. I'm going to get minus cos x minus root 3 sine x. And I'm setting that equal to 0. So this time, root 3 sine x is going to equal minus cos x. That means sine over cos is going to be minus 1 over root 3. Tan x is minus 1 over root 3. When we do inverse tan, we are going to get a negative solution to begin with. I can just modify this now. So let's make it a minus and put 1 divided. So we get minus 1/6 pi, or minus pi over 6. I'm going to reject that one. But then I can add on pi and pi again, just like before. I get 5 pi over 6, or 11 pi over 6. I just cross that out just to make it clear. Okay, there we go. Use your answers to part A1 and A2 to find the coordinates of the points A, B, C, and D. I should just say that the diagram shows the graph of the gradient function. That's really important. This is not y equals f of x. This is y equals f dash x. So first of all, we can look at where the f dash x is 0. It's going to be here and here. So A is going to be the coordinate pi. So it's where it's 0, pi over 3. And then the y value is 0. And then C will be 4 pi over 3, or 4/3 pi, and 0. And then B and D are actually the stationary points of f dash x, but that is where the derivative of the derivative is equal to 0. The derivative of this curve is the second derivative. So it's going to be where the second derivative is 0, which we found before. We're going to get 5 pi over 6. And for D, 11 pi over 6. Just got to work out now the magnitude or the y value. You got two options. You could put it back into f dash x. Okay, that is a safe strategy. So put in 5 pi over 6 into this one here. So minus sine 5 pi over 6 plus root 3 cos 5 pi over 6. And we get minus 2, which means the other one, because this is, it's going to just be a single trig function that's been translated, the other one's going to be 2. You might remember, or you might, a different way to do it would be to kind of use the ideas of r cos x plus alpha. And then when you come to find r, you always end up squaring these numbers here. Use Pythagoras' theorem. So it's 1 squared plus root 3 squared square root, which again gives 2. So that's actually how I did it. I just looked at it and thought, yep, I remember that topic. Okay, that's how you get the r. Sometimes you draw a little triangle with 1 and root 3, and then you can also work out the alpha, but we don't have to do that here. It's only one, couple of marks. We've already, this bit is just like the very last part of the last mark as well. So yeah, either sub in or use that idea, but those are going to be our 4 coordinates. Explain how to use the graph of the gradient function to find the values of x for which f of x is increasing, or f of x increasing when the gradient's positive. So when f dash x is greater than 0. So it's going to be where the values are above the x-axis. Just trying to think of, oh yeah, so yeah, look, values of f dash x that are greater than 0 or above the x-axis. Using set notation, write down the set of values for which f of x is increasing in this domain. So it's going to be from 0 to pi over 3, although it's not actually going to include pi over 3. I'm actually going to go straight for set notation. So the sets of x such that 0 is less than or equal to x, which is less than pi over 3, or it's the sets of x such that between 4 pi over 3, but not including it. 4 pi over 3 is less than x, which is less than or equal to 11 pi. Hold on. Sorry, not 11 pi over 6. It's actually all the way up to 2 pi because it is still positive at that point. And just to say the or, we actually put this union in. Nice one.